last one. We will be talking about multi-master replication, and this is Nalini from OpensourceDB. She will be talking about multi-master replication, what are some of the nuances of multi-master replication, and we'll touch base on some of the extensions that are available. Right? Spock is one of them, and then she'll be focusing on that Spock extension. And probably, if time permits and internet doesn't collapse here, we'll give a quick demo on Docker and setting up a 2-node cluster where we will be able to showcase multi-master replication. Right?
Hello, good evening. And why multi-master replication? Before that, we all know replication means copying of data from one server to another server. And this is our primary and replica, and this is master server. Before multi-master server, just a quick note about primary replication means the single server which acts as a master table which made changes and updates on master table, and another is copying of those tables. That is slave server. So, and why multi-master? Why we are changing to multi-master replication means, sorry, sir. All the nodes are worked as a master. All the nodes are worked as a master. If one master fails, remaining 2 or more than 2 are worked as a masters. So there is no gap between. No fails actually while we are using those tables.
Right. Let me focus a bit on the open source extension that we have available, which is called as pEdge platform. Okay. If you look at the traditional replication that we have available, right, the primary and replica, the multi-master clusters. Now, what is the distinct difference that we see is every node that is available in the cluster, the entities that are available in the cluster, will be able to take reads and writes at simultaneously. Right? Asynchronously, you will be able to read and write any of those nodes that are available as part and parcel of the cluster. Now, when you go back to now, why do we even need the multi-master replication as one of the use cases? I don't know why. More of looking at why the users are looking at writing, right? So to look at it from a perspective, right? The users are coming from multiple geographical locations, and you are looking at transactions spawning from multiple app servers, multiple geographies where you have certain compliances and stuff. Now if you look at edge computing, right? So there is an edge computing concept which is also being dealt with, and then there is a new stack called as Jamstack, right? All of these things are looking at a broad scenario which is closer to the user, right? Now, how do you want to go ahead and set up your data nodes closer to the user? You got to have multiple replicas, and then all of those replicas should be in a position to take reads and writes, right? That's the exact multi-master cluster that we have on the right hand side. All of the nodes we will be able to go ahead and do reads and writes. But from a compute standpoint, do we have a shared compute? No, the shared compute is the only way to go about and perform the reads and writes on all of the clusters? No, right? There are other options available also, right? We've got Yugabyte, we've got CockroachDB, we've got CitusDB extension, hyperscale extension also on the similar lines. Whenever you're looking at multi-master use cases, it is what is the exact target that you have in mind, whether it is the data residency that you would want to grab, whether you want to look at multiple instances, multiple nodes that needs to be available. Make sure your entire database platform is highly resilient and reliant, and ultra high available. Right now, nobody's talking about high availability anymore, right? It's ultimate reliability and then ultimate high availabilities and stuff, right? That's one of the reasons why we have this multi-master cluster. And quickly going and taking a look at the pEdge platform that we have, right? pEdge is one of the new companies in the block in the Postgres ecosystem that has built an extension called as Spock, which is just a component or the piece of puzzle in the entire multi-master replication. And what platform has is a standard Postgres engine, right? Now this, which is PG15. Now pEdge supports from PG15 onwards, and then we could see that PG16 beta 2 is also being supported as part and parcel of their pEdge platform, right? Now, whenever you are looking at now changing your ad hoc or a single master instance to a multi-master, right? You would look at the transition and make sure how smooth the transition is, right? How do you go ahead and make sure your applications that are working on a single master are transitioned to a multi-master, right? So for us to achieve that, we got to have two main important components. One is whether the standard Postgres is supported or not, right? And then the second is what are the other transition steps that we will have to take into account, right? How much of lift and shift, what are the changes that we need to do, and how do we achieve the whole process as streamlined as possible, right? Now looking at the platform, there are three components, right? All the other components that are part and parcel of Postgres ecosystem still holds good for us, right? The three components are the node controller and the cluster control, the two utilities that make sure the whole orchestration layer, right? The whole orchestration of how many nodes that you are creating, how your nodes are getting created. The node CTL and the cluster CTL are more of the orchestration engines, right? For us to go ahead and build the database, for us to go ahead and build all of the ecosystem around the multi-master. And the third one is the Spock extension. Again, the Spock extension supports from PG15 onwards, right? PG15 and PG16 are supported. Now, we'll talk a little about the Spock extension and then go about see what some of the features are available. Spock supports asynchronous multi-master, like I said, right? So we will be able to look at, hey, this is my node 1, node 2, node 3, 3-node cluster, and then all of the nodes are eventually getting consistent. You are able to write to all of the instances at once, right? That's the asynchronous multi-master replication. And how does it do? It's all logical replication, right? Complete under the hood is PG logical. So PG logical always had PG logical 2, which is still an open source logical replication extension. And then quite a few customers are using in the real time world wherever they need PG logical replication. Now we picked up the PG logical code and then did some conflict resolution engine related changes into them, and then Spock is the output. And any multi-master replication, whenever you are looking at it, right, it is more of, hey, you are now serving us from a multi-masters. Now how about the conflict resolution, right? How about we insert into multiple nodes and make sure there are as less conflicts as possible. And then Spock comes with, it does not have the crystal ball, right? It does not have the magic to do the entire conflict management. It does provide you all the basic nuances of how do you handle the conflicts and how do you resolve those conflicts and make sure you have a sane data in place from a data integrity standpoint. And any extension and then any resolution and the conflict management standpoint, you would need a strong monitoring and management in place, right? Spock, now we will be looking at some of those metadata tables in our Docker demo. The monitoring side of the story is more of what are some of the tables, the metadata tables that Spock provides, that Spock installs, and makes sure that all of the conflicts are being recorded in those tables. And then how do you make sure what is the action that has been taken, right? If there is a conflict that got originated, and then how does that conflict that got resolved? And all of that is clearly documented and then clearly available in the Spock metadata tables. And then looking at the Spock initialization, I will not go into the installation of Spock. I mean, I'll leave to your judgment as to go to the pEdge and see how the extension can get installed and so on. But it's straightforward, right? Download the code and then create the extension using your create extension command, right? But again, like I mentioned, Spock is more of the logical replication, right? Logical replication. How does it? How do you even look at the dynamics of logical replication? It is your subscriptions and the publishers, right? The handshake between the publisher and the subscriber, and making sure all of your walls that are part and parcel of the logical replication are safeguarded by your replication slots, right? It's a simple, straightforward setup. You create a node which is part of your multimaster and multimaster cluster node, and then create the replication set, which will make sure that all of your wall files that are part and parcel of the transactions that are happening across the nodes are being safeguarded and exchanged between those nodes. And then the last one is creation of subscription. And then these subscriptions make sure that whatever the node 1 is generating from a workload standpoint, that is being transferred to the node 2. And then ultimately to the node 3, whenever you are talking about a 3-node cluster, right? So basically, if you look at the whole structure, you create a node, create a replication set, and then create a subscription, right? Anybody that uses logical replication here on production, right? I see few hands. Any other guys who are using logical replication? So quite a few hands, right? So we know that the underlying features of logical replication, right? What exactly is part and parcel of logical replication? Here at pEdge platform, and it's more of converting them and then making it a multi-master stuff, right? Any question? Which node is the originating node that is triggering the conflict, and how that target node has received that, and what is the exact conflict rule, right? Update wins, insert wins. There are 6 fundamental conflict resolution engines that we have, right? All of these 6 are incorporated into Spock, and it picks up from the LSNs, and then for Spock extension, it is always the commit timestamp, which helps us to ascertain, hey, which is the first row that got originated, and then the originator has the control or not. Right?
Right? So you know that your use cases, you are going to foresee some of those conflicts, maybe use case 1, 2, 3, and then probably you try to write the rules so that those rules are in place, and whenever those kind of transactions occurs, these conflict resolutions gets invoked, and that's how the resolution is mitigated, and it goes on, right? So it's a bunch of predefined rules. You already do that because you know your workload, and that's the basic assumption you are making on that, and that's how you know the workload pattern, right? But how intelligent are you going to say if there's a new kind of a transactions which you don't have a conflict resolution rule? I mean, that's where I'm sure this thing is going to break, right? Do you agree on that, first of all?
I would not agree to the assumption part, because the 6 conflict rules that we have, right now, we'll not go more deep into those 6. All of these 6 conflict engines have the capability to make sure 99% of the use cases are solved, right? There will be 1% of use cases that would require custom triggers, right? And then these custom triggers, as database users, we have the provision of creating those custom triggers and making sure hey, if the 7th conflict occurs, right? If there is a 7th type of conflict that occurs, what should be the action from the database standpoint, right? So in case of update means you go ahead and take a look at the commit timestamp, right? In all the other 5 cases, there are other nuances that kicks in. Now, when we say the only the predefined conflicts, right? Anything over and above those predefined conflicts, right? How do we handle? It is the customized code that user has to write. So in a nutshell, simply, if there is a conflict that we are seeing and Spock is not only Spock, right? For that matter, any customizers and understand the database use case and then write the similar routine to make sure your conflict is handled.
So still,
I know this is a pretty vast topic, and then I would not want to get into the conflict resolution at the moment, but yeah, I would say a customized solution, and that's something we should be able to do.
yeah, because that you are going to end up in a situation that the rules are not going to work, and there is something new coming up, and your code breaks, and it's going to be more of a reactive approach. You understand that pattern, and then you write a trigger, something like that, custom rule, and then you try to fix it. But if something is gone wrong, I mean, obviously it is gone. Yep. Yeah, so that's the caveat.
How do you repair the conflicts have occurred? Yes, shit has happened. How do you go ahead and fix that? Is what we will have to be get expertise on, which we are still work in progress.
Thank you.
Metadata tables, a couple of views, and then a bunch of sequences that makes sure that the entire gamut of your the multi-master nodes, their subscriptions, their wall LSNs, the entire origin of how your entire logical transactions are happening. So we have just laid out a simple example here, right? Now there are 2 node clusters that we will be setting up using Docker, and we'll see how pGPench could be set up on them, and how do we see that. Any questions before we jump into the demo? Yeah, Pa. Can someone hand over mic?
Like I have seen BDR supports around 64 nodes geographically, but do we have any kind of node support, means across the world? And if yes, how we are going to handle the latency part, means how good if we are having a terabyte database system in the production, how this works?
Multi-cloud system, the answer is yes. pEdge platform supports Azure and AWS. So you will be able to provision nodes on both AWS EC2 instances and Azure compute engines. The second part of the question is, so frankly, we have tested with 5-node cluster across some of the regions in US, Europe, and a couple in APAC. The latency is something the cloud provider gives us, and then an addition of that latency is how much of transactions you are seeing, what's your workload. When you say 1 terabyte of table, what is the requirement for you to look at? Do you have to transfer the entire 1 terabyte database to one region or another region, one node to another region, right? That's a fundamental question you would ask the application folks, you will ask the entire business, right? So you pick and choose, and then we've got logical replication as the underlying engine for pEdge, right? And then the multi-master thing. So you look at it from a logically pick and choose what tables that you would want to do, right? What tables that you would want to logically transmit between your nodes, right? That's one thing, one suggestion I would have. And then the second is, look at it from a latency standpoint. Latency is going to be there, right? It's something that you will not be able to avoid. But how much of latency that you will be able to go ahead and avoid is, again, it looks at testing how much of data that you are pushing, what you are doing with your logical decoding memory, right? There are certain parameters that are available in PG16, right? That would help your lift and shift of your data, and then the initial sync of your data also.
Put latency.
And conflict resolution is not maintained, and there are basically a few set of guidelines that Spock follows in making sure those conflicts are resolved in an amicable way. with less data integrity issues and making sure all of the nodes are eventually consistent.
Okay, thank you.
Right? PG Logical 3, which is a closed to source version of EDP, has got some amount of conflict resolution, but it does not qualify to be a multi-master solution or a data residency solution, I would say. I would not be in the
Hari, one more question.
We do not handle the non-primary key
Okay.
tables.
So even
So there is something called as replica identity full, right? Which is a really, really shitty solution. You'll have to lift and shift the entire row. You create a unique identifier for the entire row when we set up the replica identity full, right? So the lift and shift between your nodes becomes slightly more than what you would want to do.
PG16 as a solution, we can specify an index.
Rajesh can be in a happy path.
Are you detecting there is a conflict after committing both the transactions? Let's say both want to do transactions with me, and both of them conflict with each other. So in that scenario, so if two transactions are conflicting with each other, do you first detect the conflict and then allow committing? So one after the other, or post commit of both? That part I did not get clearly.
While applying the change, you detect whether it is conflicting or not. Using the
It is always the origin and the target, right? So apply is the guy who takes care of, hey, I do see a
Part of handling, some action might be needed there, right? So you already acknowledge back to the user.
just don't apply that change. That's it. You skip that.
That doesn't stay with what output you give to the user, right? You said yes, I am successfully committed. So the user is under an impression that he has committed the transaction. Now
that's where the commit row has the greater timestamp, and make sure that takes the precedence to be identified and rectified.
okay.
We will be making sure all of these PPTs are available by weekend or latest by Monday, right? Go hit the GitHub, download the Docker, and then these are the simple commands that we will be doing. And if the internet breaks in between, pardon me, but let me just give it a try. Now, couple of steps that are part and parcel of our setup, right? So the phase one is more of making sure these node 1 and node 2 are talking to each other via SSH, right? That's the first phase. And then from the second stage onwards, we are going ahead and setting up the Postgres. And then for the demo purpose, we are using the 16 beta 2 version, right? Which is the latest that got released last week, right? So pEdge supports 16 beta 2. Now we go ahead and install. So again, like I said, all of this orchestration is part and parcel of the nodectl command, right? Which is a utility that we saw as part of the pEdge platform, right? And then we are setting up the pEdge, we are installing pEdge, and then we are going ahead and making sure these things are happening, right? We are setting up the node 1, we are setting up the replication slots, and then making sure all of those replication slots are talking to each other between this node 1 and node 2. And then the last one is creating the subscription on the node 1, which is talking to the node 2, and then vice versa, right? That's how we will be able to communicate between these two nodes. And then I'll let you guys go ahead and dig into the GitHub repo, right, where you've got Bootstrap shell script files are there, and then a bunch of Docker files are there, right? The one prerequisite is we should have EL9 binaries, right? So your VMs should be EL9 compatible, right? Enterprise Linux 9, which is the Rocky 9 or the Ubuntu 22.04s. And then coming back to the setup, it's more of we are setting up the orchestrating the whole cluster both on node 1 and node 2, setting up some of the parameters that needs to be there, right? Similar to wall and score level as logical, making sure it is the logical wall between transferring between the node 1 and node 2. And then the next set of commands are using the nodectl command, nodectl Spock commands, where we create the node, we create the replication set and create the subscriptions, right? These are the exact, I mean, this is the output that you would see, you know, when you do the Docker compose up and build processes. Now I've got two Docker containers that are available here, right? Now container node 1 and node 2. Node 1 is connected here, and what we did is, let's just quickly take a look at what is Spock extension, what are some of the components that are part of Spock extension, right? So Spock has got these a bunch of functions that makes sure all of your transactions are transferred between the nodes, and then making sure the communication between these nodes. How do we grab the exact LSN, the origin LSN, the catalog xpin, and all of the moving parts that each and every row, each and every transaction of Postgres requires, right, from both of the nodes, right? That now it captures all of it, and then has got bunch of these tables. Like RK here asked about conflicts. How do we gather the information around conflicts? How do we monitor the data around conflicts and manage some of the resolutions that are implemented? And then the second set of tables are more of your metadata tables, right? How many how many tables are part of your subscription, and how many replication sets are there? Are there replication sets which are specifically for insert only, update only, delete only, or the entire set of DMLs and stuff? Good.
Even the sequences we can add as a part of replication?
Yeah.
Okay.
Sequences are supported as part and parcel of Spock.
Okay.
Also doesn't help it, but PG Logical has couple of functions that will help us in synchronizing the sequences values. The vault does not transmit them, but then your PG Logical synchronization function helps you do that. So the first and foremost thing that I said now is, and the replication slots and the subscriptions that we write. So we are on node 1 and then taking a look at all of the stuff here. Right? So this is the subscription that is sending the data from node 1 to node 2, right? So look at the slot name. It is sending the sub on created on node 1. I mean node 2. We are on node 1. Whenever we create a publisher, and then the subscriber obviously gets the slot, right? So we are sending the data from node 1 to node 2. And then what is the replication slots characteristic? All of them, right? So DDLs are transmitted, your entire gamut of DMLs are transmitted now. Let's go ahead and quickly do a PG bench initialization on demo. Anybody is really irked by this PG bench command, because again, logical replication does not help us from a DDL replication standpoint, right? So we are resorting back to, I will go ahead and do the entire DDLs on my node 1 and node 2, and then make sure that the data transmission and the replication between both node 1 to node 2 and node 2 to node 3 are going to be in space. Now what we did, so we did a Docker Compose build, and then we did a Docker Compose up, and we saw that all of this stuff is placed. And now when we go ahead and do this, right, so BG bench demo, and we initialize, some 100K transactions are inserted into the PG bench accounts, tellers, and the 3 tables, right? And then PG bench history does not have a primary key, as we all know, right? So that table will not be added to the replication slot, and then it will not be added to the subscriber. What I'm going to do is I'm going to go ahead and copy this and make sure that the change that makes sure all of the conflicts are handled, and then conflicts are copied, and then conflicts are monitored on the node 1 and then node 2 side, right? We'll go ahead and do that. So again, this is the patch that may or may not go on PG17, right? Now if it gets into code, you don't have to do this alter tables and making sure, right, all the log old values needs to be done, right? Now if I go ahead and add, now I'm going to simply run the command which says nodectl Spock repset, right, and add the tables onto the subscriptions, right? Add the tables which are part and parcel of your PG edge, PG bench are added to your stuff. So look at the last error. So all of the 3 tables are added, right? Your PG edge account, branches, and the tellers are added, but the history is not added, right? Somebody asked a question about no primary key, how do I handle this stuff? It is like replica identity full needs to be done, which we have not done yet. Both of the time up. Right, so once I have added here, what we will be able to do is we will be able to do all the transactions between node 1 and node 2, and then the entire communication will be flowing between these database tables, right? Because we have added these tables to the subscriber, we have made sure all of the transport that needs to be done between the node 1 and node 2. The entire setup is done. Once we run the PG bench now with -r now, we'll be able to see a lot of that stuff. I will go ahead and just leave this running. Any questions, folks? Again, like I said, this is all more asynchronous, right? So they are eventually consistent. So the onus is on where the data is being written to. As long as these guys do not have the latency, you do not see the write latency. And then the replication between the nodes under the hood, obviously they will have latency. And then like RK says, there will be conflicts that will be arising, right? All of this process takes time, and then that's the reason we say eventually consistent.
Yeah, but since customer use latency or in microseconds, so essentially what we are saying here is, it's a good solution, but it has a very specific use case. Obviously, we cannot compare with all the multimaster application, especially, I don't want to quote the name of Oracle RAC was to this, it's nowhere comparison.
I wouldn't even go to the Oracle guys and say, hey, we have an equivalent, we cannot give them a run for money yet.
Yeah. So what are the caveats, or what are the use? I mean, let's be very open that this solution comes with its own caveats. Okay, latencies.
Let's grab and answer all of these questions.
Yeah, anyway, we had that planned.
Yep. All right, any other questions, folks?